So let's go through the different pieces. Basically, today's lecture is about 4 things that we are including in the exam. Files, sets, dictionaries, and classes. And, just for the sake of argument, I'm going to put lists here too, just so that we can do comparison between them. But lists are not actually included. Okay, now do I have your attention? Okay. Am I quiet? Just don't make me yell too hard. All right. So files are the only different thing from this group because everything else is a container. So let's do files first. And files are technically very, very simple, right? So a file is a text file. Generally, if you have different types of files, like a binary file, you will have a different way of accessing it. But generally, for the sake of this class, what we are really concerned about is a text file. So a text file basically contains a long string with new lines, because you may have multiple lines. And to access any file, like this one or this one, you basically have to open it, iterate through it, and close it. Okay? So if you are reading it, you have to open it just to read. So you have to open it to say that, open polls.txt, which is this file. So when you open a file, you have a pointer to the very beginning of the file. Then at this point, you have 2 options. You can either read the whole file with an f.read, which will return you the whole contents as a single big string that has the new lines in it. Then if you wanted to do something with that file, you could in fact convert the whole file into a JSON object, into a dictionary, or you can use the JSON load file to load the whole thing. There's no such question in the exam. Or you can find individual lines by splitting it. But if you are going to read individual lines, it is much more preferable to use a loop, which is in fact an iterator. So for line in F. Now the most important thing to remember that when you read a file like this, that every line that you read also includes the new line, right? So if you were to read the whole file and split, then you will have lost the new lines if you split on new line. So let's see the 2 differences here. I'm going to save this. All right. So for example, if I were to open polls.txt and read all the lines, which is this huge string with the new lines, and if you took this and split on a new line, now M is a list of strings without the new line, because that's what I split on. If you want to do a separate thing, let's try to do a separate list where I read each line. I'm going to reopen because now I actually read the whole file. Now I'm pointing to the end of the file, so I have to reopen it. So I'm going to read each line and I'm going to put it into a list. I don't need to necessarily do this. I'm just doing this to show you that when you look at M2, M2 actually is strings, the same strings, except these strings have the new line, whereas if you were to split, these strings don't have the new line, right? So basically, both ways of looking at the file is okay for small files. But you have to remember that in one instance, you don't have new line. In the other instance, you do. And if you, of course, have a massive file, then in that case, you don't want to read the whole file and split. If it's possible to do your operation, read one line, do your operation, read the next line, instead of keeping the whole file in memory, right? So as you start to become more aware of complexity, you don't want to really read everything into your program if you don't need it all in your program, right? So, and in that case, this method is the better way to go through a file instead of reading it all. But in any case, be aware of the difference between the two methods. This is all I'm going to say about files. Do you have any questions about files? Okay. So files were from last exam, and there is a file question, but there is nothing really very deep about this, right? But these four are interesting, right? So basically, these four are what we spent most time on this part of class, especially sets, dictionaries, and classes. So all of them are complex objects, and lists, sets, and dictionaries are all containers. So they are containers, but in many ways they are different, right? So let's try to see some ideas here. I'm going to get rid of this. So the lists, when you put a value, the value is basically put in a certain location. So every time you have a value, that's true, I'm going to go back to the animals. Apparently the pig has died, so I'm going to use a different animal. That was a very loud pig. It happens that this person has 2 cats and 2 dogs. And let's say, what else do they have? Parrot. Okay. So when you have a list, you basically refer to an element by its location. So that animals 1 of 0, animals 1 of 1, they are all specific locations. Okay. And that what we know is that if I write animals 3 is equal to animals 1, is animals 3 a new list? No, it's an alias to animal 1, right? They are pointing to the same list. So anytime you make an assignment in lists, it basically is just an alias, right? So animals 3 is an alias. If I wanted to create a copy of a list, what can I do? If I want to create a copy of animals 2, what I would do is I can use list of animals 2, which will create a copy, or I can use slicing of the whole list. Okay, so in this case, animals 4 is a copy of animals 2. But I only make the copy at the first level of items. I take the 0th item, make a copy, 1st item, make a copy. But I can only make a copy if they are actually simple values. We'll talk about that in a second. Okay, so both of these work. They are both different ways to make a copy of the list. So in that case, animals 4 and animals 2 are totally different lists after this operation. So if I were to add something to animals 2, it is not added to animals 4. Whereas animals 1 and animals 3 are the same thing. So if I add to animals 1, it is also added to animals 3. Yes?
When you do animals 4 equals list animals 2, is that making all of animals 2 that list inside a list?
No, it's making an exact copy. So for example, print animals 4, print animals 2, Okay? They are all the same exact thing. It's just a copy, right? So it basically copies every item. So there's a little bit of complexity here that we are hiding. This is not relevant to sets because sets cannot have this. But if you had a list inside this, right? This is still a copy, except that since 1, 2 is a complex list, actually the 1, 2 in one list is pointing to the 1, 2 in the other list. Okay? This level of complexity, I never try to trick you in an exam, but there is more to it than just a copy, right? So if it's a simple value, you create a copy. If not, you create an alias. Okay, so let's put that aside for a second. Okay, so now come to sets. So sets, what do we know about sets? Well, one of the things we know is that you don't have duplicate values. In fact, you basically take a value and you create a hash and then you store it at that hash value. So if you had the same value multiple times, it will hash to the same area and you will only store it once. So if I want, for example, animals to set, I can take a list and convert it to a set. Okay. Okay. So the first thing that I do is I remove all duplicates. I only repeat each value once. The point of a set, it's a mathematical set, is that you cannot repeat a value. So that's like the most important part of a set. So that will make our lives interesting because basically, I can ask questions like, is dog an animal in this set? Or is parrot an animal in this set? Or is bird an animal in this set? Things like that. So the problem, though, is that since sets are not actually stored as index for a specific location, you cannot just say things like animals to set of 0, right? There is no location 0, so this will actually give an error, right? It's a set object does not support indexing. You cannot index it. You cannot go through it one by one. You cannot. You can go through it one by one, but not by 0, 1, and 2. One of the things you can do is you can iterate through a set to print the items. So you can say something like, for A in animals to set, print, let's say, A, right? So you can iterate through a set, and it will go through the items, but it will go through these items in arbitrary order because there is no specific ordering. It could be whatever the ordering is. It's determined by what the hash key is, but if I tell you to give them in sorted order, this is not guaranteed to give you a sorted order. Okay? In fact, it is not sorted. So generally, if I want to actually print everything, and if I don't care for the order, you can do that. One of the things you can do, though, is you can take a set, you can convert that to a list, and then you can sort that list. Okay, so if you wanted to print it in the sorted order, you can do that. You can do that in 2 ways, right? So print set in sorted order. So you can first find the list version of animals to set. Then you can take that and sort. Then you can go and iterate through this, and then you can print this. Okay? So now this one is sorted order. Or you can do that in a simpler way, because there is a function that takes a set and then creates a sorted list of the items in it. Okay? So in fact, let's just do this for a second. So sorted is a function that takes a set and creates a sorted list. So then you can iterate through this. So, for A in sorted, so you can get the same result by writing this, right? So sorted will create you a sorted list of the items in the set. Now, a couple of things that are important to remember about sets. The sets, you cannot put everything in a set. It is not going to like if you put, let's say, a dictionary in a set. Things that you put in a set should be hashable. Okay? So you can only put hashable things in a set. What are hashable things? Anything that's a simple value is hashable. So these are things like integer, string, tuple of simple values. Generally, Boolean is not good, but it is possible. Floating point is not good because of precision problems. What other data types do we have? I think this is it. These are kind of the best values. There may be some other things that are hashable, but not really very recognizable. Because, like, for example, if I have a set, and then I create a set B of A, it will tell you that a set is not hashable. Because I tried to create a set and then put a set inside a set, but it cannot take a set and then hash it to a value. So you can only put simple things in a set. But once you put things in a set, you can do lots of interesting things. So what are the functions that we know? So we know that you can add a value to a set by add value. So you can add a value. You can remove a value, but only if that value is actually in the set.
Does it bring up an error?
I think the remove does, right? So a.remove will actually give you an error if it is not in, but a.discard will not. A.discard will fail quietly if the value is not in it, but if it is in it, it will remove it. So it is the safer one. So
Another question.
Mm-hmm.
Does remove only one of the values?
There's only one value. So it's like, you had 3 things before when you converted to a set, but that history is lost, right? So it doesn't remember there were 3 things. If you want that kind of thing, you come and take my database class. That's the bag logic. The set logic is that there's only one copy as far as the set is concerned. So, so discard will not give an error. So no error if 2 is not in A. Okay. Then we can basically check if a value is in a set by the in value. So this checks if a value is in a set or not in a set, right? So if I had so I can check that 1 is in A, 3 is not in A, right? And one of the good things is that if you do care, that this is a very fast operation. In the sense that I don't need to go and check if every single value is equal to 1, if I want to check if 1 is in A, because all I know is that the value 1 is hashed to a memory location. So I take the new value, I look at the memory location that would contain 1, if it is in the set, and if it is not, I know it's not. I don't need to check the other elements. So this operation is actually order of 1 operation, which is very nice. Whereas if you had a list to check if a value is in a list, you would have to go through and check every single item to be able to say, no, it is not in a list, right? So if A is a set, the same thing is true for this one. So this would be order of n if A is a list, which is very, very important distinction. And then you can take 2 lists, and then you can do set operations. So you can take 2 lists, let's say 1, 2, 3, for set 3, 4, 5, 6. Okay, so A and B will find elements that are common to both sets, and then it will create a new set with those values, right? So it doesn't modify A and B, but it creates a new set with the common values, right? So this is intersection, common values, so new set of common values in A and B. In fact, the AND is kind of telling you what you need to know. So A and B will be 3 and 4. A union B is all the values that are in either set. It's like an OR operation. So, but you are not going to repeat a value more than once. So if I were to do D equals A or B, D will have everything, 1, 2, 3, 4, 5, and 6, but as it is a set, I don't repeat a value. And so this is union, all elements in A or B. And then the other one we learned is set subtraction. So A minus B is all the values that are in A but not in B, which would be, what would be in A minus B? All the values in A, 1, 2, 3, 4, that are not in B, which is 1 and 2. Okay? Now, important is that B minus A and A minus B are not the same thing, right? The order is important because all the values in B that are not in A are not the same as vice versa. But the AND and OR, it doesn't matter. You can write in any order, right? A and B is the same as B and A. Those are symmetric, but subtraction is not. Right? So subtraction is not symmetric. Is not necessarily the same as B minus A. So be careful when you write this. So now the interesting thing is that everything we just said about aliasing is also true for sets, because sets are containers. So if I have a set A, and then I were to say AA is equal to A, AA is not a copy of A. AA is just an alias, right? So basically AA and A are pointing to the same set. So if I were to change one, the other one should also be changed. So if I were to add 1,000 to 1, it is added to AA also, right? So it's the same exact logic. So AA is an alias. So that means that they are basically pointing to the same thing. If I wanted to create a copy, I would actually do this. It's like the same thing, right? It's like you had the list of something, now you have the set of something. So if I were to create a copy, now if I add another value, it is also in A, it is also in AA, but it is not in BB because that's actually a copy, right? So now BB is a copy of values from A, but not an alias, right? So the same logic applies. Now to create a copy of a set, you use the set. You're not going to be able to do this with dictionaries, I'm sorry. I'm sure there is a module that does that, but there is no one-line thing to do that with dictionaries. So this is kind of all that really we need to know, right? You cannot index it, you cannot keep it sorted, you cannot have more than one copy of something, but it is very, very effective to find if a certain value is in a set. And if you really want to iterate through in a sorted order, just use the sorted function, which is what we learned. So that's this one here, okay? Any questions on sets? Okay, so now we are going to add one more level, because dictionaries are just sets such that for each value, for each value in the set, you have additional information, right? So dictionary is set plus additional data. So what do I mean by that is that dictionary keys are stored as a set. Okay? So for dictionary, it's like a list, but I'm going to store the indices, right? In the list, your indices were 0, 1, and 2. In the dictionary, I'm going to store them as hashed value, right? And I'm going to store that as actually a set. So basically, if I were to create a dictionary, so the dictionary is initialized like this, okay? And if I need to create a new key, I can just put that key. And my key can be anything that is hashable, anything that goes into a set. What that means is that it's okay to have integers, strings, tuples. These are all hashable things that I can have a set of. That means they can also be a key. But you can mix and match. You can have a dictionary that has some integers and some strings. It's not really that useful, like, dictionary, but you can actually have that, which actually does happen. So, for example, I can have one key that is, let's say, bol1, and the value can be anything. So your value can be a number, a string, a tuple, a list, a set, a dictionary, an object from a class, a combination of those, right? Anything is possible. So it could be anything, but I'm going to basically put like a color just for simplicity. There is no like add something to a dictionary. You just index a new thing and it will create a new key. All right? So you can really have arbitrarily complex values, and we will talk about that in a second. Now, one thing is that the keys of this dictionary are stored as a set. So if you were to call, let's write this down here. So if you were to say bol1 is in bols, you're actually asking if bol1 is in the set of keys for this dictionary. Okay. So this is the most important distinction to remember, that dictionary keys are stored as a hashed value, as like a set. So checking if a key is in a dictionary is actually an order of one operation. So So you can check if something is in a dictionary very simply by doing this. Let's add one more bol. Okay, always has to be red. Now you can do other things to a dictionary. There are functions that operate on a dictionary. So what are those functions? You can delete a key from a dictionary. I think it's del bols. This is an operation that I never use, because why would you put stuff in a dictionary if you're going to delete it? But you can. So it will remove the key and the value associated with that key. And if you try to delete something that doesn't exist, it will give you an error. And as far as I know, there is no discard version of this for dictionaries. Again, this is a completely unused operation. I'm going to put this one back. Then you can take a dictionary and you can create a list of all the keys in it by polls.keys. Okay? So it takes the set of keys, it creates a list. Now, if you wanted to take this list and print it in sorted order, you can do something like this. So polls.keys creates a dictionary, creates a list containing the keys in the dictionary. Okay? So if you wanted to have for key in bowls, print key, this will print all the keys in bowls, right? But this is since the keys are stored as a set, there is no ordering. Okay? So if I were to do this, they could be in any arbitrary ordering. It is currently happens to be in bowl 1, bowl 2, bowl 3, but there is no guarantee that, or we can give them names as, bowl Z, roller, and bouncy. Right? It is not in actually alphabetical order, right? There is no ordering because it's stored as keys. If you wanted to, so if you actually did this for key in polls.keys, print key, that is also a kind of arbitrary order because it takes the keys and creates a list for you, and then you iterate over that list, but it's not in any order necessarily because it is just whatever order it happens to grab the keys in. If you wanted to actually iterate through the keys in sorted order, you have to take the list and then you have to sort it. In the same way we did, right? There happens to be a function that does that in the same exact function that we had for sets. What was the function that take a set and then give you a sorted order? Sorted, right? So you can do the same thing for a dictionary, which will sort the keys and then return them in the sorted order to you. Okay? And these are actually in sorted order. Right? So when you're iterating through keys, there is no guarantee that they will be in sorted order unless you tell it to sort. I mean, if you really wanted, you can take the keys, store it in a list, sort it first, and then iterate through that. The result is the same. Okay? So that means if you actually have to iterate through sorted order, you have to take the set of keys and then create a sorted order over it. Okay? So this is the only really important thing to remember about dictionaries, that the keys are stored as a set. The value can be anything. So often what you want to do is you want to actually do some operation over the values. So in that case, we have to add the value. So the value that is stored at this location is bowls of key, right? Take the value that is stored and then print that one. That's trios, there you go. Okay? And that the same thing is true for this one. Okay. Now, in the very unlikely event that you don't care at all about the keys, you only care about the actual values that are stored, in that case, you can iterate only through the values. There is a function called bowls dictionary.values that will return you a list of the values that are in it. So in this case, the values are strings, but if you were storing dictionaries as values, it will be a list of dictionaries, a list of something, right? So you can do that. So this creates a list containing the values in the dictionary. As a general advice from me to you, try not to spend your time trying to learn very specialized functions. Just learn 3 functions, and then do what you can with these, because that's really so much more useful than going to a new language or some other place where you cannot use a specific function. It's much easier to learn just a simple thing, and then, as you get comfortable, you can get fancy. So any questions about dictionaries? So the same logic applies, right? So if I were to say bols2 is equal to bols, is bols2 a new copy or is it an alias? Bols is a dictionary. When I say bols2 equals to bols2 is alias. Thank you, right? So if I were to add a new bol, to my dictionary, it will also be added to bols2. And there is no, I don't think there is in fact something like dictionary of, there is such a thing. All right, so you can create a copy. It will only create a copy of the first level, but apparently you can do the same thing. So it's the same logic for every single container. It's made in a way that they all operate the same way, so you understand one concept, you can apply it to others. I never tried this, but apparently it works. Any questions about dictionaries? Okay. So these are all complex data types, so it's not going to create, the Python is not going to create a copy of the same item, because the item, the container, may be massive, right? It could have thousands of things. So it's making it so that if you wanted a copy, you be explicit. If it was like a simple data type, like an integer, creating a copy is no problem, so Python will do that automatically for you. But as you get fancy, it's not going to do that. All right, so the final thing in our group is classes. So classes are not containers, and they are also containers. So they are actually containers, but they contain not different copies of the same thing, but they contain any variable that you want to put inside. So let's put a new one for this classes. Actually, I'm going to do classes, but also play with this problem that I put up, so we can solve a few problems, and then we can kind of think through how we want to do this. So, so this is like homework 8, which I am sure you all love now. Yeah, that's nice. Okay, so I'm going to start with this simple one. So the idea is that in classes, you store different types of attributes. So a class is basically an abstraction of an object, such that whenever you use that object, you expect that it has certain attributes. So I'm going to use the class as a way to encapsulate all those attributes. So basically, a class will have different attributes, and they're all going to be attached to the class object. So class object is going to have things that are coming out of it. And depending on your application, you can decide what those are. So for example, this is similar to the stuff I posted on Piazza, but a little different. So I'm going to create, for example, a class for creating and storing bols. Okay. So, and this is the information that I have for bols, that each bol has a name, a color, an X and Y, and a radius, right? So generally, depending on what your application is, you have some number of attributes that each object must have. And then you may also add other attributes over time, or you may have attributes that are hidden from the user, but you need to keep track of for being able to do things that you need to do for that class. And generally, they encapsulate kind of all the information you need for a certain type of object. So think about it, for example, if you have a student object, right? What are the attributes do I need to know about a student? Like suppose you go to a student information system, what kinds of information that system knows about you? It knows about your name, your RIN number, your address, your email, right? So these are all the things that define and is important for a student. So that's what the class is going to contain. So depending on the application, you start to define what those attributes are, and then you can basically keep refining it. So what I want to do is, I want to create a bowl class that will contain this kind of information. And I'm actually going to write a little piece of code to read all the bowls from this text. And I will put this code and the data online so you can play with it. Okay, so I'm going to create a class called bowl. Okay, and it basically says that it inherits from an object. An object is a thing where you can attach values to. And the first thing that you want to write when you define a class is how do you create objects for that class. So this is called a constructor. A constructor is defined for all classes because other than that, you don't know how to create a class. And this is where you define what are the variables, what are the attributes of that class. So in Python, the constructor class is called init. Okay? But different programming languages will have different ones. So when you create a new object, and this is going to be the object itself, and I'm going to basically attach things to it, right? And what are the things that I'm going to attach will depend on the meaning of it. So I want to attach, for example, a name, a color, x and y, and radius. That means when you create a new object, give me all these values from the outside world, and then I'm going to attach them to attributes of this object by basically saying that attach to self a variable called name and assign this the value of the variable that called name that you feed into it. You can give this a different thing. You can just call this n, and you can go make this n, right? It's just take the value n and attach it to name. It just happens that over time it becomes easier for you to keep track of it by just giving it the same name. So it's kind of, first when you see it, it's confusing, but over time it's a useful convention, right? So this and this don't have to have the same name, but it is kind of useful to remember that the variable there is going to be matched to a member attribute called self.name. And attach also to this object a color value, a x value, y value, and a radius. So this is a simple constructor that tells me how you can construct a bowl. And if the bowl is basically has these attributes, you have to give them from outside, and then I can create it. So I can actually write a simple piece of code to read data from my file and then create bowl objects using this kind of code. Okay? So whenever I write code inside the same file that I defined the class, I don't need to import it because it's already defined, so I can use it without importing. But if I want to use the class in a different file, first I have to import the class into that file. So I am going to open this bowls.txt. And I'm going to read every single line. So bowls.txt is like this. It is delimited by this. So I am going to take line. I'm going to get rid of the new line at the end. I'm going to split on this. And I'm going to create a bowl where the first item is the name, color, x, y, and radius. Okay, and then I'm going to create a list of bowls, and I'm going to append this bowl into it. Okay. So if you want to see, balls is a list of balls, right? But it doesn't really know how to really print an information for a specific ball, right? So basically, classes are kind of this very specific thing. All I told this class is to attach these values, but I didn't give it an explanation of how to print those values. So if I were to do that, I need to define a thing called an str function. That will basically has to return a string that I can use in many different places. So anything that is underscore underscore basically is a internal Python method. When I implement that method, Python can call that function in various different ways. So init is just a constructor. Str is one of the first special ones. And if you properly implement str, it should return a string. So let's return a string. So let's say ball, the name of the ball, put the color at x and y with radius, something like this. I guess I don't need this. And I need to now write that I'm going to put self.name, self.color, self.x, self.y, and self.radius. Okay. So this will return a string that has this one nice way of writing things. Okay. Now, one of the things that I will do here, I don't have time to have this cause an error and then go back and fix it. But I expect that x and y to be integers and radius to be an integer. Will they be an integer in this case? No, because I read it from a string, right? So now you have two options. You can write a constructor class that helps you. So, or you can say, okay, this one was an x, this one was y, so I should convert them. Or you can say that whatever you give for x, y, and radius, before I assign, I'm going to convert them to integer. If they're already integer, this is okay. It's not going to give an error. But if not, this is going to actually make the comparison. So this way, I've already made my life easier, so I don't have to remember when I feed this value to make it an integer. So the class kind of encapsulates all the stuff that helps me. Okay. So now if I do this, it still doesn't know how to print a list that contains these balls. But if I do balls of 0, I can convert that to a string by using this method. So this method, I can use it as str, or I can use it as like this. Both methods work. So this is the normal way you would call any method. But since underscore underscore has other mappings, this also maps to it. And even more interestingly, if I do print balls of 0, it will actually take the str and then print that string. So it makes my life much easier to actually have this method. So let's do one more thing before I go further. So balls of 0 is a ball. What happens if I say B2 is balls of 0? Do I create a copy of the ball that's stored at that? So what happens if I take the balls of 0 and then change its color to blue? What happens to B2.color? So the same way you have sets, lists, dictionaries, whenever you make an assignment to a container like a class object, then that is also an alias. That is not a copy. Okay? If you want to create a copy, you have to write a method that takes an object and creates a copy. Right? So we don't actually have such a thing. If you wanted to create it, you can create a method to do that, but it's not given by default. So the same logic applies. So we can do the same thing with people, but let's do a couple of interesting things. So I have a list of balls that I have here. Let's do things like, for example, so let's say, let's find colors that are only used once. Okay. So balls are different colors. I want to find colors that are only used once. How would I do that? So what's the first thing you think about when you hear something like that? Go through in your mind, what are the things that you know? What do you think? What do we know? So I can probably use a dictionary to count how many times each color happens, right? I can try to find sets of colors for each object and then do set subtraction, but that doesn't seem to work, right? Luckily, over time you have seen things like this. So one of the things I can do is I can go through each ball and then find how many times each color has happened, right? So I'm going to use a dictionary of all colors, which is going to have key as a color, and value is number of times color is used. Okay. So now I'm going to go for B in balls. Okay. I am going to add all colors. So the color of B is B dot color. Okay. So now let's look at this for a second. So balls is a list of ball objects, right? So this is a list of ball objects. So this is actually a single ball, right? And I'm going to go through individual balls. Now this B here, is it a copy of that ball or is it an alias to that ball? Right? So you had this list of balls here, like this, right? So B is going to be this ball first, whatever it is. Then it's going to be this ball. Then it's going to be this ball. Am I going to be copying the ball or am I going to be aliasing the ball? It's always an alias, right? Whenever you assign something. So whenever you have a for loop, there is an implicit assignment here that B is equal to first ball. B is equal to second ball, right? All for loops are an assignment. But if what you're assigning is a complex object, then you are not creating a copy, you are creating an alias. Okay? So C is B dot color. Now I want to basically put that in my dictionary, but first time I see a color, it is not in my dictionary, right? So first I'm going to check if C is in all colors. If C is a color that I have seen, then I can add 1 to the value, right? Else, this is the first time I've seen it, I can set this to 1. If I didn't do this, because if that key did not exist, this will give me a key error. So this is something we've done in class a few times. Now, given that I've created this dictionary, I can find all colors that have a value of 1. So now that I found how many times each color happens, so find how many times each color occurs. Now I want to find all colors that occur only once. So for C in all colors, if C all colors, so this C is now a key because this is a dictionary. If all colors that C is equal to 1, then print C. Okay, so pink and magenta only occurs once. What if I wanted to print the colors in sorted order? If so, all I need to do is say, go through the colors, the keys in the dictionary, but go through the keys in sorted order. So now I have this. Magenta and pink. Okay. So let's create another class for the people. And then I'm going to write a simple simulation like the one you did in the homework, much simpler. But now people basically have slightly different model. So people have a name, an x and y, a dx and a y, and then number of steps. So this person is going to walk for 250 steps. Okay? Whereas this person is going to walk for 100 steps. Okay? So let's create a new one and call this people.py. So we have name, x, y, dx, dy, and steps. So self.name is equal to name, self.x is equal to x, self.y is equal to y, self.dx is equal to dx, self.y is equal to dy, self.steps is equal to steps. Okay? And generally, anytime you define a function, you define a class, I would define an str. So it should return, not print a string, that has person S at person D, something like this. And the same thing we did, I'm going to convert this to an integer right here, just to make my life easier. And for this, I am only using integers, so I'm going to put all integers here. Okay. So I can do the same thing. So for line and so name, x and y, dx, dy, and steps. Okay? So I'm going to have people as a list, and then I'm going to append this person. So if I wanted to print all the people, I can say for p in people, print p, right? Because p is basically going to use the str method and it's going to print. Right? So if you get more sophisticated, you can add more things like moving at %d and %d for this many steps. So you can add more sophistication like dx self dy self steps. So anytime you want to add more things, then this is more sophisticated. Right? So now at this point, I'm just going to kind of show you how you use both of them to write a simulation like the one you did for homework 8. But do you have questions about classes in general? Any questions? All right, so now let's try to use these classes in this problem. Basically what I want is, I want people to walk for a number of steps. So I'm going to start with basically the people that are in the file. Then I'm going to have them walk until they reach the end of their number of steps. And then when nobody is moving, I'm going to stop the simulation. Then I'm going to have people pick up a ball when they reach, if they are within the radius of a ball. So people here is a single point, but the balls have a radius. If you are within the radius, they are going to touch a ball, so I'm going to keep track of which balls they touch. Okay? So, but I want to first do the part where people walk, and then we can add the ball part a little bit. So now I'm going to first use the classes that I defined elsewhere. If I want to be able to create classes from that object, I need to import them. Generally, if you're looking at an object, if you want to read something that's in it, you don't need to import it. Importing is needed for you to be able to construct new objects. So if I want to bring the objects, the classes, into my program, the same namespace, what I can do is I can say from people import star. That's as if that class is defined inside my function. And from ball import star, again, this is as if it's defined in my function. Now, when I import them, whatever I wrote in the ifName.main of these classes, right, none of this is going to execute because this is, when you import, this part is not executed, right? It will only import things that are above here. The same thing is true for this one, right? None of this is going to execute. It's only going to only import the stuff that is above here, which is the definition. So first thing that I want to do is to create my balls and my people the same way I did here. So I can actually take all of this and copy. So I'm going to take this, copy here, and then I'm going to take this and copy here. There we go. Okay. So I'm going to create people and balls. If you want, you can put these in a function. It works the same exact way because I imported ball to my class, so I can use the same code that I used in here. So now I'm going to basically iterate indefinitely until everybody moves as many steps as they want, right? And when nobody is moving, at which point I'm going to stop my simulation. So this is a little bit more complicated, as I'm realizing now. So I'm going to write a while loop to test this, okay? This is not necessarily the best way, but we will see. You can do something like, for example, at first everybody is moving, right? When somebody stops moving, I will subtract something from my list. So this is a little more complicated solution. We can do it both ways. So let's say now moving. I will try to do the more efficient one, length of people, right? So, so now, when I'm implementing this, it becomes obvious that I need to keep track of who's moving and who's not moving. So at first, everybody is moving. So I'm going to add a variable that says somebody is moving at first by default. When I reach the number of steps for that user, I'm going to turn the isMoving to be false. So that will be basically essentially stopping that person, right? So while not moving is greater than 0. Now I'm going to move each person once, right? So the first thing I want to do is, so first I need to know what time is. So time is equal to 0. First thing I'm going to do is increment time with 1, right? So now move each person once. Okay. Well, that's easy to do because people have this dx and dy. I'm going to write a simple move function. What it will do is it will add the movement dx and dy to each person. Okay. Right, there you go. Bless you. So, for P in people, move that person. Okay? That's very easy. Okay. Now, I need to figure out if this person was moving, and now he stopped, right? So that means I should not really move everybody. So what I'm going to do is, if P is moving, then I'm going to move this person, right? Because I added this is moving variable here. So if it's moving, move that person. Then check if time is greater than P dot steps, right? And in that case, P is dot moving is equal to false. And non-moving is one less, right? So this person was moving, now he's not moving. So I increment the number of moving people. So this person is going to stop. And since I set is moving to false, I'm not going to move them the next time. And if you want, I can print a statement saying that this person has stopped, like this, okay? So let's see what this does. Hopefully I don't have an infinite loop. All right, let's see what we see. All right. So let's see what time step they stopped in, right? So let's see if we did this correctly. So stopped at time okay. So now I actually stopped it at 76 because it's supposed to move for exactly 75 steps. It seems that this is incorrect because if it has to move for 75 steps, I should stop at 75. So I am actually going to make this equal to P dot steps. Okay. Now the next thing that I want to do, so now I know that my simulation runs and it stops. I can check, for example, now people have to see if they can pick up a ball, right? So now I need to see if each person in their new position is in the radius of a ball. So, so for P in people, for B in balls, okay? Now I need to check if the person is in the radius of a ball. You can write that method in a ball or in a person. So let's write it in balls. Ball B dot within region XY, and I'm going to send in the person's X and person's Y. Okay? And I'm going to write this, a method that returns true or false. If so, I am going to add to the person this ball, pick up, or touch ball B, right? So this is kind of shows you how I write my programs. I'm going to implement one method in ball class and one method in people class. So let's write this class, touch within ball, touch within region. So it's a ball class. So we are going to define within region. So remember it was B dot something. That means the first element, the first argument to the function is the ball itself, the method itself. So I will always add a self for that. Then it takes an X and a Y value. And I'm going to check if X and Y is within the region, within the circle. So what I need to do is I need to find the distance between X and Y and the center of the ball, and it has to be less than the radius. So let's look at the distance. I'm going to finish this one, and then we are going to stop for a second. But let me finish this. Okay, so if the distance between the point and the center is less than the radius, return true. So now that means I can check if the person is within the region of a ball. Now I need to do something about touch ball. So I'm going to add I'm going to basically have a new thing called balls, and I'm going to actually have a list, okay? And well, what I can do is maybe I can have the list of balls, the set of balls. Okay, so there's a lot of things going on in here. So let's do this one finally. So I am sending in a ball into my method as an argument. I can then reach all the attributes that are attached to the ball. So like name, right? I'm assuming names are unique. So I can attach the name, and I can take that and add it to the function, to the set, which is self.ball. So this is a set, so I can add a value to it. So because I decided to use a set, okay? So let's see if this actually gives an error. Radius is not defined because it's actually self.radius. Okay, let's do this again. People object has no attribute touch ball. What did I do? Touch balls, all right. Okay. All right. So now let's just check to see what we have done. So when I'm finished, when I'm out of the thing, I am going to print what balls are touched by each person just to see if it's actually working, right? So when I'm finished with my simulation, okay, so you can see, for example, these two people did not really touch anybody, whereas these people touched all of these, and this person touched only two, okay? This kind of shows you how I actually implement these kinds of classes by slowly adding what I need, okay? All right, good luck in the exam, and if you have friends who are taking the exam, make sure they remember.